Okay, so we're going to move on to 5.2. 5.2, we're going to talk about probability rules or rules of probability. So this is going to be some of the stuff that you're somewhat familiar with. Okay, so we're going to start on page 314. Looks like 314. Probability models. Probability models. So there's a definition there. A probability model is a description of some chance process that consists of two parts: a list of all possible outcomes and the probability for each outcome. The list of all possible outcomes is called the sample space. Okay? So again, and then there's the definition above on page 315 also, it says an event. An event is any collection of outcomes from some chance process. So let's say that we're going to roll the dice. We're rolling the dice and we're going to say, so we're going to have two 6-sided fair dice. So if we go ahead and say the first dice we'll call, so let's say the chance of me running, so I can get a 1, I roll a 1 and a 1, 1 and a 2, 1 and a 3, 1 and a 6, and then I can roll a 2 and a 1, 2 and a 2, 2 and a 6, and so on and so forth till we get to 6 and 1, 6, 2, 6, 3, 6 and 6, right? So this is the entire sample space when I roll two dice, right? Two dice, right? I can get 1 through 6, and I can go on the second one, I can go 1 through 6. Okay? So let's say that I want to know what is the probability of me rolling doubles. Okay, so me rolling doubles. So what are the chances of me rolling doubles here? So I have to find out how many different outcomes there are for me to roll a double, right? So it'd be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. And there will be 6 different sets, right? So the chance of you rolling a double is there are 6 different outcomes that satisfies that, and your total sample space is 36. So the probability is going to end up being 1/6. Okay, probability is going to end up being 1/6. All right. So if you go to page 315, there's a little green box there, finding probabilities, equally likely outcomes. If all outcomes in the sample space are equally likely, the probability that an event A occurs can be found using the formula, right? Number of outcomes, 6. Well, there are 6 different times, right? You can do that. You can get doubles, right? And divided by the sample space. Okay. So here you go. So that's how you do that. Okay. Let's say that I asked you the probability of me not rolling a double. Okay. So then I'd have to count all the other ones, right? All the other ones that are not doubles, correct? And how many of them are going to be there? They're not going to be 6. So 6 of the ones that when I had doubles. So how many of them are not doubles? 30, right? Because there were 36 of them. And you take away the 6 doubles, all you have left is 30, right? So then the probability of me not rolling a double is 30 over 36, which is 5 over 6. Okay. There's a special word for this, and we call this the complement. So this is the complement of 1/6, or the chance of me rolling a double, right? So the chance of me not rolling a double is actually 1 minus the chances of me rolling a double, right? Because this is the same as 1 minus 1 over 6. Or you can look at it this way, right? 36 over 36 minus 6 is the same as 1 minus 1 over 6. Same thing, right? Because 36 would be the total sample space. 6 would be the doubles that I roll. So if I don't roll a double, that would be 36 minus 6. And that's how we got to 30 in the first place, right? So 30 divided by 36 is 5 over 6. We call that the complement. Okay. Let's go and do the example there. Spin the spinner. So it looks like there's a spinner there, and I have 3 different colors, and it looks to me like they are equally likely to happen. So let's read what it says. We have a spinner with 3 equal sections, red, blue, and yellow. Suppose you spin the spinner 2 times. Okay, so what can I get? I can get red, 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 blue, red, yellow, yellow, red, yellow, blue, yellow, yellow. Or I can get blue, red, blue, 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 yellow. Okay, so there are 9 different types of things that I can get here, right? So A, give a probability model for the chance process. So here it is. This is a sample space, this is the probability model, right? Okay. And each of them are likely, so there are 1/9, so there are 9 different ways, there are 9 different things that can happen, and they're all equally likely, okay? So each of these represent 1/9 of a probability, right? So B, define event A as spinning the blue at least once. So which ones have blue at least once? So that would be 1, 2, 3, 4, 5. So there are 5 of them out of the 9 different things that can happen. So it's 5/9, right? 5/9. That's the answer. Okay. So we're good there. And then let's go flip the page to 316, basic probability rules. So the basic probability rules, if you look at number 1, it says, if all outcomes of sample space are equally likely, the probability that event A occurs is the number of outcomes in event A divided by the total number of the sample space. Number 2, probability of any event is a number between 0 and 1. We already talked about this, okay, 0 and 1. Number 3, all possible outcomes together must have probabilities that add up to 1. Okay, here's another thing. So when you add up all of the eventualities or probabilities, they have to come to 1, right? Because they all have to add to 1. Number 4, the probability that an event does not occur is 1 minus the probability that the event does occur. We just talked about that, right? So if you go underneath there, there's a definition of the complement rule. The complement rule says that PA complement is equal to 1 minus PA. So in other words, so the probability that event A occurs is this. 1 minus that event is called the probability that the complement of A occurs. Okay, so there's that little C there. That stands for complement, okay? All right, so that's that. And then let's go to the top of page 317. There is the mutually exclusive addition rule for mutually exclusive events. 2 events A and B are mutually exclusive if they have no outcomes in common. Okay, no outcomes in common. All right, so they never can occur together. So that is if P of P, A, and B is equal to 0. The addition rule for the mutually exclusive events is you just simply add them together, right? So in other words, mutually exclusive events are in a Venn diagram, which we'll talk about just here pretty soon. okay, that they look like this. This is A, this is B. There is no overlap together. They're not going to happen together. In other words, what is the probability of a number being an even number and an odd number, right? They're mutually exclusive. You cannot be an even number and an odd number together, right? So they're mutually exclusive, okay? So in other words, if they are mutually exclusive, another way to say this is that P A cap or A cap B or A and B is equal to 0. Okay, it's a 0, so it's a null set. There's nothing there, okay? If this is true, then PA or B, the combination of A or B, is going to be equal to probability of A plus probability of B. Because as we already know, PA, if it's whether it's mutually exclusive or not, PA or B is the same as PA plus PB minus PA cat B, all right? We know this, okay? We'll talk about this later, okay? But this is just a case where this guy here is equal to 0. So if this is equal to 0, okay, then obviously PA or B is going to be PA plus PB, right? And when this is equal to 0, we also call that mutually exclusive, okay? So let's go ahead and see if we can go and read the M&M question. Avoiding the blue M&M. Okay. Problem. Suppose you tear open the corner of a bag of M&Ms, milk chocolate candies, pour one candy into your hand and observe the color. According to the Mars Incorporated, the maker of M&Ms, the probability the model from the bag is as follows. So you have that much percent of each of them to get for you to get. A, explain why this is a valid probability model. Okay, so let's look at the probabilities. Okay, so what has to happen? They all have to be between 0 and 1. Okay, and they all have to add to 1. So if we add them all together, okay, I'm not going to do this, but it looks like it's going to be 1. Okay, it is 1. All right. B, find the probability that you don't get a blue M&M. So if you chances of you getting an M&M is this, right? The chance of you not getting an M&M, a blue M&M, is this, right? So it's a 0.793. Okay. C, what is the probability that you get an orange or a brown? Orange or a brown. Okay, so again, this is one of those things where they're mutually exclusive, right? You cannot get a brown and an orange M&M together at the same time. Okay, so then they're mutually exclusive. So you simply just add those two probabilities together, right? You would add the orange and the brown together, orange and the brown together, and that's all you would do. Okay, so we're going to stop right here for today.